So multiplying and dividing rational expressions is just like multiplying and dividing regular fractions. I have two fractions here, and if I wanted to multiply them, I could multiply the numerators, multiply the denominators, and then I could factor the numerator and denominator. Now I'm just going to do that in my head in this case. We have a common factor between 3 and 9 of 3. So if I factor that out and divide through the two 3's, I get this left over. And I have a common factor of 4 on these. So if I factor out a common factor of 4, I'm left with that. And so I'm reducing to 2 over 3. Now what we often do is, instead of bringing everything together and then reducing it, we often just reduce it from the beginning. So same idea, common factor divides away 3, common factor of 4 divides away, and we're left with 2 over 3. Okay, so the key thing is the same, is that you need to cancel factors. Alright, simplify the following and state restrictions first. So in this expression, everything is multiplied numerator and denominator. 14 times x squared times y cubed, and so on. Everything's already factored. So we can look at our restrictions. X and y can't be 0. We can't substitute those values in, or we'll get division by 0. And now we're pretty much good to reduce. So let's multiply across the top. We're going to have 14 multiplied by 10 times x squared, which is x to the 4th, y cubed times y to the 10th is y to the 13th, divided by 25 times 21. I'm just leaving the numbers that way because they'll be easier to reduce if I don't put them together as a big number. X times x to the 7th is x to the 8th, and y times y to the 1 times y to the 6th is y to the 7th. Okay? Factors numerator and denominator. Got a common factor between 14 and 21 of 7. So the common factor of 7 cancels, and we're left with 2 and 3. The common factor here of 5. 5 into 10 is 2, into 25 is 5. Here we have 4 factors of x and 8 factors of x. So 4 factors of x cancel in the numerator and denominator, and we're left with x to the 4th. And on the y's, 7 factors here cancel with 7 factors here to leave us with 6. And so we are left with, multiplying our leftover numerators, 4y to the 6th divided by 15x to the 4th. Alright, so I want to multiply these two rational expressions together. Again, a little bit more complicated. This time our numerators are not factored because we have to think of that as a chunk. These are all chunks. So the black bracket times the black bracket are 2 factors, and same thing on the denominator. So I can factor the numerator, y minus 3 times y plus 3. Here I got a common factor of r times r minus 1. Here I have a common factor of r. That's going to be r times r squared minus 1. But then I'm going to be able to factor that down again. So I actually get 3 factors, r times r minus 1 times r plus 1. And here y plus 3 is just a factor of 1 times 3. 1 times y plus 3. Alright, so everything's factored, so I could multiply numerator and denominator. So I can write, let's bring everything together. I'm just going to put that r out front so I can see it better. Divided by r times r minus 1 times r plus 1 times y plus 3. Alright, so I have 4 factors on the top. Remember, the brackets are big factors. Our restrictions, by the way, are 4 factors on the bottom. R can't be 0, or 1, or negative 1, and y can't be negative 3. And now I can cancel things that are the same or opposites. So here we go. R divided by r is 1. We have y plus 3 divided by y plus 3 is 1. We have r minus 1 divided by r minus 1 is 1. Alright, look, everything, so much of this has gone away, and we are left with, on the top, 1 times 1 times 1 times this bracket, y minus 3, divided by r plus 1. So if you put the same values of r and y into the front and into the back, you should get equivalent expressions. Now, just one other thing I want to say here is that you'll notice that after I factored and I multiplied, I brought everything together as one big expression, okay? If you'd rather just do the canceling on this stage, at this line, that would be fine as well. So for example, you would cross-reduce here. It's kind of like when you have two fractions, numerical fractions, and you just cross-reduce across the multiply sign, numerator and denominator, same idea. That's totally fine. That saves you a little bit of writing. That divided by that. It will still obviously come out to this. So for division, we know that we can change division of fractions into multiplication. So this expression would become a over b multiplied by d over c. Okay. The only extra thing you got to worry about in terms of restrictions is that if you start with your original expression, we know that b and d can't be 0 because that would cause division by 0. But when you turn division into multiplication, we also got to take into account now that our numerator has become our denominator, so c can't be 0 either. So let's divide these two rational expressions. To do that, we need to factor our numerator and denominators. So we have a common factor of 2 here, 2a squared minus 5. In the denominator, there is no common factor, so it's just 1 times a minus 3b. Divided by, factoring here, common factor of 3, 2a squared minus 5. And down here we have a common factor of 2, which leaves us with, I'm just going to write this off on the side here, 2a squared minus 9b squared. And that can factor further, a squared minus 9b squared, as a difference of squares, a minus 3b, a plus 3b. Okay. And so my restrictions so far, I do my restrictions after I factor. A minus 3b can't be 0. So if I bring the 3b to the other side, basically a can't be 3 times b. And in this case, a can't be negative 3b. And then we got to worry about the fact that our numerator is going to become our denominator here on this fraction. So 2a squared minus 5 can't be 0, which means 2a squared can't equal 5, which means a squared can't equal 5 over 2, which means a cannot be plus or minus the square root of 5 over 2. Okay, so all of these are our restrictions. The next thing we're going to do is we're going to take our factored expression and we're going to write it in terms of multiplication. The first fraction times the reciprocal of the second. And now that everything's in factored form, chunk times chunk times chunk times chunk times chunk, and same idea on the bottom, we can cancel opposite or equal chunks. We have this term the same as this one, so those divide to 1. We have this expression the same as that one, so those divide to 1. And so we're left with 2 times this, so 4 times this, divided by 1 times 3, 3. So this expression is equivalent to our original expression. And one final example. So let's divide this expression. We have to factor all our numerators and denominators. We've got a trinomial. Two numbers multiply to negative 10, add or subtract to negative 3. 5 and 2. The denominator, we're going to have 5 minus a times 5 plus a. And over here there are no common factors in the numerator and denominator, so we leave them alone. Okay, remember you can't cancel out the a's. Very simple way to show that you can't cancel out the a's. If you canceled out the a's and thought the answer was 2 over 5, you can see that the answer wouldn't be 2 over 5 if a was 1. It would be 3 over 6, which is not equal to that. So you can't just do that. Okay, so please don't. Alright, let's do our restrictions. A can't be 5. A can't be negative 5, because that makes that bracket 0. And a can't be negative 5. We already have that. And then when we reciprocal our second fraction, we got to be sure that this will become a denominator, so a can't be negative 2. Alright, let's rewrite our division in terms of multiplication. A plus 2 times a minus 5 over 5 minus a, 5 plus a, times reciprocal of the second fraction. And now I can cross-reduce factors that are the same. A plus 5 and 5 plus a are the same, so they divide to 1. A plus 2 and a plus 2 are the same, they divide to 1. Now we're left with, I'm just going to write this out for clarity, a minus 5 over 5 minus a. Some of you will immediately recognize these things as opposites. Something divided by its opposite is negative 1. If you don't recognize it that way, you can think of factoring a negative out of the denominator. Okay, notice that this expression here with the negative 1 factored out is equivalent to that. So if you want to do it this way, you then have two factors that are the same that divide to 1. And so 1 divided by negative 1 is negative 1. Hard to believe that no matter what you put in for a, as long as you don't put in those values, this expression is going to come out to negative 1.